Density. Density is a ratio of mass to volume. It's a fundamental property. Different substances have different densities. When you change the size of an object, you change its volume and you change its mass, but you don't change its density because the density is a ratio. So a piece of wood has a given density. You cut it in half. Each of the pieces still has the same density. We calculate density using that equation. Density is mass over volume. So here's an example. A sample of liquid has a volume of 22.5 milliliters and a mass of 27.2 grams. Calculate the density. This is an example of a problem that uses an equation. This is not a unit conversion problem. We're still going to apply the sort, strategize, and solve. So sorting, we're going to take the numbers and write them down. 22.5 milliliters, 27.2 grams. It says calculate the density. Density, okay? Density is equal to the mass divided by the volume. There's an equation for that. That's an equation you should memorize. Density is mass over volume. Well, 22.5 milliliters. Milliliter, is that a unit of volume or of mass? That's volume. So that's the volume. And gram is a unit of what? Mass. So that's the mass. So to calculate the density then, let me show you this. Density is the mass divided by the volume. So that's the mass, 27.2 grams, divided by the volume, 22.5 milliliters. So 27.2 divided by 22.5. How many sig figs should my answer have? 3. So 1.20, that's the third sig fig. And then I'm just going to write down 2 more, 8. The units there do not cancel out. Grams divided by milliliters. And so when I round this, I'm going to get 1.21 grams per milliliter. The density of the liquid. Any questions?
So when I was trying to do the online stuff last night, so whenever we're multiplying, is that when we make, we don't just choose one unit over the other, but we put it in the form of a fraction like that?
Yeah, so you deal with units like variables in algebra. So if you have x divided by y, there's no simplifying that, right? You just have to stick with x divided by y. So here are units, grams divided by milliliters. They're not going to cancel out. We can convert them to other units of mass or other units of volume, but they're never going to cancel out. And so we just leave them as a fraction. Any other questions? So when we've got a problem like calculating the density, here we have an equation that's involved. And so your map is that you're starting with these different quantities. You're going to use an equation to find the desired result. Another example. Customer purchases a platinum ring that has a mass of 9.67 grams and displaces 0.452 cubic centimeters of water. Is the ring genuine? And the density of platinum is 21.4 grams per cubic centimeter. It doesn't matter what shape or size a piece of platinum is, it will always have the same density. You could make something out of aluminum or silver that might look very much like platinum, but it's going to have a different density. And so by finding the density of this ring, you can identify whether it's platinum or not. So let's write these numbers down. This is the sorting step. So we got 9.67 grams. And then we've got 0.452 cubic centimeters. Now this might be a little confusing. It says it displaces this much water. What does that mean? Well, one way to measure the volume of an irregularly shaped object, if you have a cube or a rectangular prism, you can get out a ruler and measure it. But if you want to know the volume of a ring, that's a bit more complicated, right? So what you can do is you can take a graduated cylinder with some water in it, and you make a note of where the volume was. And then you put the ring into the water. What's going to happen to the level of the water? It's going to rise. It's going to go up. So you make a note of that. The amount of water, the amount the level of water changed is the water that's displaced by the ring. That is equal in volume to the ring. Okay, so this is a very quick way to measure the volume. So when it says that it displaces this much water, that's telling us the volume of the ring. So this is equal to the volume. And 9.67, it even tells us that's the mass. So we want to know if it's platinum, if it's genuine. So what we're going to do is we're going to calculate the density. It doesn't specifically come out and say, calculate the density. So you kind of have to imply that, well, this is how I would find out if it's actually platinum or not. Density is mass divided by volume. So the mass, 9.67 grams, divided by the volume, 0.452 cubic centimeters. 9.67 divided by 0.452. 21.3938. Each of these numbers has 3 significant figures, so this should have 3 significant figures. So that rounds to 21.4 grams per cubic centimeter. Is it platinum? Yeah, it is. Now notice that this number is not exactly the same as that. It does round to that, which is convenient, but it's a little bit less. Because when we make these measurements, there are small amounts of error. And so if this came out to 21.3 grams per cubic centimeter, I would still conclude that it's platinum, because it's very close. And anytime we make measurements, they're going to be off by a smidge. So the answer here is not 21.4. The answer is the answer to this question, is the ring genuine? The answer is yes. So this comes up on lab reports sometimes where you do all this great work, but you don't actually answer the question. You did all the work to answer the question, but I need the word, okay? The answer to this question is yes. If you do all the other work and leave off the word yes, you're going to lose some points. And you might say, well, that's a little harsh. I'm trying to teach you a real-world skill. When you try to get a job and you're filling out a job application, you better answer the questions that they ask and answer them completely. Because if you don't, it reflects badly on you, and the guy reading through all the resumes and applications is just looking for any excuse to throw some out. So if you're answering the questions weirdly, like 21.4 grams per cubic centimeter, instead of saying yes, that's a great excuse to toss yours into the circular file. We can also use density as a conversion factor because it's the relationship between the mass and the volume of that particular substance. So if we have a liquid substance with a density of 1.32 grams per cubic centimeter, what volume would we need to measure to deliver a mass of 68.4 grams? So let's just approach this as we've been doing the other ones. We'll take the numbers and write them down. 1.32 grams per cubic centimeter. Write that as a vertical fraction. Grams divided by cubic centimeters. The other number is 68.4 grams. What am I trying to find? Volume. What volume? Now, it doesn't specify a unit. So then let's look at these and think, well, we could probably do this as a unit conversion problem. This is a relationship between grams and cubic centimeters. That looks like a conversion factor. This is just grams. Can't do anything with that. So let's start with this one. So we'll start with 9. I don't know where the 9 came from. Previous slide, perhaps. 68.4 grams. And I want to get to volume. Well, what unit of volume would be convenient here? Centimeters cubed, because here's the density. This gives me the direct relationship between grams and cubic centimeters. So I could go from grams to cubic centimeters just in one step. Density is a conversion factor. 68.4 grams. I have one arrow. I have one conversion factor, one fraction. Grams to cubic centimeters, grams to cubic centimeters. And then I'm going to write gram in the denominator, so those cancel. Then I need numbers for this relationship. They come from the density here. 1.32 grams per cubic centimeter. If I need to put a number here, what would that number be? Be a 1. So 1.32 grams is equal to 1 cubic centimeter for this liquid. So I have 68.4 divided by 1.32. How many sig figs? 3. So 51.8, write down 2 extras, round to 3, 51.8 cubic centimeters. This is how I want you to do problems involving densities. If you're calculating the density, you have to use the equation. If you're converting volume to mass or mass to volume, use the density as a conversion factor. I know there's another way to do it, but students do all sorts of screwy things and get the answer wrong. This is easier. It really is. This is a table from your textbook. It gives densities of some common substances. And you may need to refer to this when doing homework problems on Mastering Chemistry. I will not require you to memorize any of these. There's only one that I would have any expectation that you might know, and that is the density of water is 1. That's not a coincidence. Density of water is 1. The rest of them, they'd be given on an exam, or you go look them up in the homework. So sometimes you'll do a problem, they don't give you the density, but you need it. You have to go look it up. Let's do an example. A drop of acetone, nail polish remover, has a mass of 35 milligrams and a density of 0.788 grams per cubic centimeters. What is its volume in cubic centimeters? Well, again, let's take our numbers and write them down. 35 milligrams, 0.788 grams per cubic centimeter. What am I trying to find? Volume in cubic centimeters. So I need to get to cubic centimeters at the end. I look at the units on these two numbers. This one, grams per cubic centimeter, could be used as a conversion factor. This one cannot. So this is the one I'm going to start with. So I'm going to start with 35 milligrams. Now, how can I convert milligrams to cubic centimeters? Yeah, we're going to need grams. I can convert milligrams to grams, and then the density here allows me to convert grams and cubic centimeters. And so I can get from grams to cubic centimeters. So 35 milligrams, 2 arrows, 2 fractions. milligrams to grams to cubic centimeters. Same as I wrote in my path. If you struggle with dimensional analysis, and most students do, be sure to write the path down. Once you get this written down correctly, the rest of it just kind of will fall into place. So if you're wanting some help with a problem, I'm going to ask to see your work, and I want to see a path. So units in the denominator, I want milligrams down here so they cancel, and I want grams down here so they cancel. We get all the units to work out, and then the units tell us where to put the numbers. So much less thinking involved. So I think this one would be the easiest to do first because it's written down right over here. 0.788 grams is equal to 1 cubic centimeter. 1 cubic centimeter for every 0.788 grams. Now here I've got grams and milligrams. I have one metric prefix. Milli stands for 10 to the what?
Third.
Close. Minus 3. 10 to the minus 3. Kilo is 10 to the 3. Milli is 10 to the minus 3. So what I'm going to do here is I've got milli in the bottom. I'm going to write what it means on the top. So 10 to the minus third grams is a milligram. 1 times 10 to the minus third is 1 milligram. So then on the calculator, I've got 35 times 1 EE negative 3 divided by 0.788 equals. And looking at significant figures, I've got 2 in the 35 milligrams. This one's exact. Densities are not exact, but this would have 3 sig figs. So this is the smallest at 2. So I'm going to have 2 sig figs here. Leading zeros are not counted as sig figs. So this is going to be 0.044 cubic centimeters. Yeah?
Instead of doing that, get 1 gram over 1 pound.
That works as well. There are other ways to put these in, and if you're good at that, you go ahead and do it. That's fine. I'm just going to follow this pattern always in the lectures, because if you follow the pattern, it always works. And I think that's a good thing. Any questions?